Now, to calculate the half deflection method, if you see, there are two loops in this circuit diagram. First of all, what we are going to do is that we are going to connect the upper loop. Once we connect the upper loop, then we'll go and connect the lower loop. To connect the upper loop, we'll connect from positive of the battery to one of the terminals of the resistor from the resistance box, and from the other terminal we'll connect to the positive of the galvanometer. Then from the negative of the galvanometer we'll connect to our key. Let's say this is our key 1, and from other terminal of the key we'll connect it to the negative of the battery. Now for half deflection method, you can see there are two loops here. This is upper loop and this is the lower loop. So we will first connect the upper loop. Once we've done the connection with the upper loop, we'll then go and connect the lower loop with the help of the shunt resistance. For the second loop, what we're going to do that we are going to connect one of the terminals of the shunt resistant to the positive of the galvanometer, and from the other terminal we'll connect to the another key. Let's say this is our key 2, and from other terminal of the key we'll connect it to the negative terminal of the galvanometer. So before turning on the battery, we'll set the voltage to 2 volts in the battery eliminator. Then we turn on the power. Now as I have turned on the power, you have to make sure that throughout the experiment the key 1 should always remain connected, whereas the key 2, which is coming from the shunt, should remain open. Only when we take out key from this particular section we are going to connect the key 2. Now if you observe in the galvanometer, the deflection is going beyond 30 degrees. So what we are going to do that, we are going to take out keys from the resistance box and bring it exactly at the 30th division on the galvanometer. So let's do a trial and error method here. Now to bring this deflection to exactly 30th division, what we are going to do is that we are going to take out 5000 ohms from this box. Always start taking out by taking the highest resistance from the box. So I took out 5000. Now once I took out 5000, I can see that the deflection is not at 30 but less than 30, which means the resistance from the box is very high. So what we are going to do that, we are going to put back this key and take out some other resistance which is less than this. So let's go with 2000. So as you see, 2000 is also not bringing. I'll increase the resistance to, let's say, one more. It goes to 1000. So now it's 2000 plus 1000 is 3000. Let's go with another small resistance. I'll go with 200. So it is not, let's go with 100. So now if you can check, I have taken out 3000, 2000 plus 1000, 3000 plus 200. When I took out 3200 from the resistance box, the deflection in the galvanometer is exactly at the 30th division. Fine. Now for this 30th division, now we are going to get half of this value. That means for 30th division I am going to get 15. To get 15, what we are going to do is next is connect key 2. Without changing resistance from the resistance box, we are going to connect key 2. And now if you can see, the deflection in the galvanometer is somewhere around 1 deflection. 1. But we want how much? We want 15. To get 15, we are going to take out key from the shunt resistance. So we take out, let's say I'll go with any random value, I'll go with 100 ohms. So let's see, for 100 ohms, are we getting 15? if you can see in the galvanometer, it is more than 15, which means 100 ohms is high. So let's decrease it. So I'll go with 50 ohms now. So if you see, I have taken out 50 ohms from here, and let's see whether we get the deflection at 15 or not. So 50 is quite less. Let's increase by some more value. So now, if you check, I have taken out from the box 70 ohms. 50 plus 20, 70 ohms. And for this 70 ohms shunt resistance, we are getting deflection exactly at 15, which is half of 30. Now, for the second set of reading, what we are going to do that, we are going to again open key 2. Now, once we have opened key 2, you can see deflection is again pointing exactly at 30. Now, what we are going to do that, we are going to again increase the resistance from the box and bring it to 28. So, let's say, since 28 is nearby 30, we are just going to increase the resistance by small divisions. So, let's say I took out 200 from here. So let's see for this value what is the resistance or deflection in the galvanometer. You can see deflection now it's at 28 division. So we got our value. So if you can see that for resistance from the box 3000, 2000 plus 1000, 3000 plus 200 and plus 200, that means 3400. For this set of resistance, we're getting deflection as 28. Now, what we're going to do that is we're going to get half the value of 28, which is 14. To get half the value of 28, we're again going to connect key 2. That means we're going to again connect the shunt resistance here and take out key from this box. So let's say I put back the previous keys which I have taken out earlier, and let's see. First of all, I'll take out 100 ohms and let's see, are we getting 14 or not. So if you can see at the galvanometer, it is more than 14. So what we're going to do that, we are going to put back this 100 ohms resistance and take out some value less than this. So I take out, let's say 50. So this 50, if you can see for 50 again, the value is less than 14. So we are going to increase resistance from the box. So let's say I increase by 20. So it's not coming here. I increase by 10. So now look, for the resistance from the box 50 plus 10, for the shunt resistance 60 ohms, we are getting the deflection at 14th division, which is half of 28. This way, you keep on taking readings up to 6 sets of readings by decreasing the deflection in the galvanometer by 2 divisions and get the corresponding half value by taking out keys from the resistance box. So now, next step in this experiment is to calculate figure of merit. To calculate figure of merit, the circuit given here is this, you can see here. So we are going to connect this circuit here. Now if you compare, this circuit is similar to the previous one. The only thing what is missing here is the shunt part. So what we are going to do that, whatever circuit we connected in the previously, we are going to just remove the shunt portion from the particular circuit and our circuit for figure of merit will be ready. So let's look here. To remove the shunt, you just need to open key 2. Once you open key 2, the entire shunt portion of the circuit will be dismantled. They will not access any current through it. Go. Now, to calculate figure of merit, the first thing is we have to find how many cells we have current in the circuit. As you can see, we have only one cell here. So number of cells will be 1. That is, power source is 1. Next will be to supply EMF from the cells. To supply EMF from the cell, we'll keep this voltage at 2 volts. And for this 2 volts, we'll try to find out what will be the corresponding deflection in the galvanometer. Now, if you see here, for 2 volts, the deflection again is going beyond 30. So what we're going to do that, we're going to take out any random key and bring it to value less than 30. Any value but less than 30. So let's say I take out 4000 from the resistance box. For this 4000 ohms from resistance box, the deflection in the galvanometer, what we're getting is 24. If you can see, it is 24. Now, for the second set of reading, we are going to increase the voltage from 2 to 4 volts and on the power supply. As you can see here, for 4 volts of power supply, the deflection is more than 25. Figure of merit says that we have to increase the resistance from the box such that the current in the galvanometer either increase by 1 division or by 2 division. So what we are going to do that, we are going to adjust the resistance in such a manner that we get deflection at 25. Why 25? Because in previous reading for 2 volts power supply, we got deflection at 24. So we are going to increase resistance from the box and increase the current in the galvanometer by 1 deflection and bring it to 25. So for resistance, 5000 plus 1000, 6000, 6500, 500 plus 200, 700. So for resistance 6700, we got the deflection at 25. So here we have increased the current in the galvanometer by 1 deflection. So this will be the reading for our figure of merit. Proceeding in similar manner, we are going to take another 1 or 2 sets of reading. So by increasing the voltage every time for another set of reading.